In this presentation, we're going to see how we can use the OAS Data Historian to log data from controllers and PLCs at a 1 millisecond frequency or as fast as the controller time cycle can execute. Typically, when using OPC server or direct driver, the communication rate to the controller is 30 milliseconds at best, based upon the Windows operating system and the controller's ability to respond to the request. I'm going to show you how, using the default product of OAS data logging, that you can actually log buffered data from the controller with arrays of data and be able to maintain 1 millisecond or even faster if the controller can execute it at that rate. We can support up to 100 nanosecond resolution. What I'm going to show you in this video is all laid out in our knowledge base. If you go to openautomationsoftware.com and select under the support menu, select knowledge base, and at the left select data destinations and then expand data logging, and there you'll see a topic to log buffered data from a PLC or a controller. Now, this is a guide that we've had for many years in how to log buffer data from controller, but we've updated it to make it easy to simulate, to run your own test scenario without a controller. And what we've done is we've created a new data emulation program using a .NET application, and this application is called Array Data Emulator, and you can see the download link directly there from the web page. There are two types of scenarios that this feature would be very useful for. One, if the communication rate to the controller is slower than your desired data logging rate. Or second, if your communications to the controller or PLC or other remote device is intermittent, where you wouldn't be able to communicate to it all the time. Maybe you would only communicate to the controller once a day or once a month to obtain records of data, and this technique can also be used to pull all of that buffered data out of the controller. So with OAS already started and the services running in the background, select the download link for the Array Data Emulator. Then we'll unzip that file, and you'll see both the source code and the release version of the Array Data Emulator. We provided the source code just so you can see how the data is actually simulated in the .NET application. So from the Array Data Simulation directory, let's go into the bin directory and select Release, and then there you'll find the Array Data Emulator. Let's run that program. Let me bring that into view for you. Step 1 of the guide talks about setting up the variables in the controller itself, as far as the array values, timestamps, and confirmation and handshaking. And if we run the Array Data Emulator and select Create Tags, we're actually going to create the tags that we can refer to that represent those variables from the controller. So let's, from the program group at Open Automation Software, let's select the Configure application. And then let's go to Configure Tags. And we can see those tags that were just created from the Array Data Emulator. And we have a confirmation tag, which is a Boolean tag, a date array, which is a string array. This will be representative of dates represented as strings that could be converted back to a date. And in the .NET example, we're actually seeing how that's done by including the milliseconds onto the date and time. But could you also bring in a date directly from the controller as well, if it supports it, but we've made this as a string array so that you can support functions like with Modbus. You could, of course, bring out characters out of Modbus, and that could be date and time as well. And of course, your OPC servers, they may not support a data type, so this is a technique that you can use to get dates from all types of controllers. We have an error tag, which is an integer. This will be non-zero if there's a problem with the OAS Data Historian logging the data. We have the ready confirmation. That's a Boolean tag. That's what the controller is going to send to OAS to trigger the logging. And then we have 3 arrays that are double data type. We have value array 1, 2, and 3. So in step 1 of the guide, you can see you would create these same variables in the controller itself. Additionally, you would support a timeout function in the controller, And so the logic that you would implement in the controller is to fill the data arrays and also the date array for all of your values that you want to log, clear the error code and reset the confirmation bit in the controller, and then set the ready Boolean to true. Then OAS will be triggered to log the values and will send back either a confirmation or error. If it's successful, it'll send back a confirmation, and then with the controller, you'll just go back to repeat all of the steps again. Fill the arrays, clear the error and confirmation, set the ready. And so it's just a continuous cycle this way. And so that's where you would need to have the array size long enough to account for this cycle time. If there's an error that occurs where the error value goes non-zero in the controller, then you would want to handle that error appropriately, possibly sending an alarm notification right directly from the controller, holding on to the data until the communications is reestablished. Also, we do the same thing, like I mentioned, with the timeout. So if the expected time response, we're not getting the confirmation or error feedback within a certain amount of time, then you would want to handle that in the controller appropriately so that it doesn't just get into a stalemate mode and does reset itself to be ready to send the ready flag again. So we've already done step 2 of the array data emulator to create the tags. Now that's using the programmatic interface of the OPC systems component that's included with the OAS installation. That's free for you to use to set up all types of configuration. And if we scroll down, we can see that it has created these tags of those data types. Now we're ready for step 3, which is to set up data logging. So let's go back to the Configure OAS application and select Configure Data Logging. We'll select the local service. We're going to define what we're going to log here in the data logging. And so let's just put in a logging group name of test. We'll make the logging active. We're going to change the logging type to event driven. And we're going to use the browse button there to select under buffer test group the ready tag. So when the ready tag transitions from false to true, that's when the logging is going to occur, and it's going to log the values we're going to specify in the next step. We'll also give the controller, or in this case the .NET application, some feedback with the confirmation. So that's the handshaking that's closed loop. So we're going to select the confirmation tag for the confirmation, and for the error tag, we'll select the error tag. Now we're ready to define what we want to log. That's done under the Tags tab. If you follow along in the guide, that is step 4. And the first thing we want to do is uncheck the option to include date and time field. So by default, it would include a date and time column. That would come from the date and time of our trigger tag. Right here, that's the test ready. Well, that's not the correct date and time if we want 1 millisecond accuracy. We want each individual record to have their own unique date and time. So what we're going to do is add a field to log from the controller. And so we'll browse for that date array tag. And we know that this is an array. You can log individual tags as well using this technique. But by using an array, it makes it a little bit simpler that we can actually set up as many items that you want to log, as many elements as you want to log. And we're going to specify 1,000 in this example, because that's what the .NET Array Data Emulator application uses. And so when we select that, we can see it has added 1,000 array elements to that. And we'll set the field name to date and time. Now, if you use that default name, that means the trend, the .NET trend, and the web trend will be able to use that by default. You can change the history of those client applications to use a different field name, but that's the default that it uses. And then we're going to change the data type to date/time. Select OK. And if you wanted to proceed to do a lot of different fields, you can use CSV import and export, but I just have a few more to add, so I'm going to go through that once again and select value array. These are the values that we're actually going to log. These are double floats. And so again, if I add square bracket 0 and then square bracket to the end of the tag name, that notes that it's an array. And we're going to add 1,000 elements. We'll change the field name to value 1. And we'll just repeat this for the other two arrays. Value 2. And one more for value 3. Okay. Next, we're ready to specify where we want to log the data to. Okay, so we could log that to a CSV file or a database. So this is specified in step 6. So we're going to log to SQL Server in this example, but you could just as easily log it to a CSV file if you wanted to. When you're logging to a database, you'd want to select the provider you want to log to. And all of the providers would work in this technique, but Microsoft Access would just be too slow for 1 millisecond recording because it does not support bulk insert, whereas the other database engines do. Cassandra does require a primary index, so you will have to do some work after the table is created to adjust the primary index to the new field that's being logged for the date and time. MySQL would also be somewhat limited. It only has a single insert into execution. There is a technique to log up to 1,000 records, but after you go above that, it starts to degrade as far as its bulk insert capabilities. So if you need to use that, I would recommend to use MariaDB instead. It's based upon the MySQL engine, and it has a much more efficient way for bulk insert. Let's use SQL Server. And so we'll bring up the SQL Server Management Studio to grab the server name that we're going to log. And this could be even remote. OAS has built-in store and forward functionality, so it doesn't matter if the database engine is local or remote. The calls are going to be pushing multiple records across in one execution. So there's my server name, and I'll come back to that in a second to look at the data. And with the database name, I think in the guide it calls it OAS Simulation. So let's just use that as the database name. And the table name, just use anything you want. I think in the step guide it uses data buffer test, something like that. All right. And then we are ready to add this to the configuration. So we select the add button at the bottom, and that has added the test logging group with the things we have defined into OAS service. So that's running now in the background in the service. So if we go back to the .NET application, we're actually ready to run the simulation to begin some handshaking. So that's in step 7, is to activate the logic in the controller or run the simulation from the Array Data Emulator application. Now, one thing you do need to know, in order to run this Array Data Emulator, you would need a license of the .NET Data Connector and data logging. If you're communicating just to a controller, all you need is a data logging license. You will not need the .NET Data Connector. It's only required in this example. So if you have a production system and you want to try this feature and don't have the .NET Data Connector with a sufficient number of tags to run the test, just contact support@oasiot.com and we'll send you an updated demo key where you can try this feature. So let's select Run Simulation. So while the simulation is occurring, it's filling in the arrays of data, and it's talking to the OAS data engine, and it's setting the tags. So let's go back to the tags, and let's actually see that in action. So here we see the values coming in. Now they look like they're static, but they're actually being set every single time. With the emulation, what we're doing is we're taking the milliseconds off the CPU clock, filling in 1,000 records, and then performing a handshake. We'll look at the ready Boolean. We see it transitioning from false to true. Every time we see that transition, it's logging 1,000 records out of the data array, and the values array. So the value array, they look static, but that's just because we're filling in 1,000 milliseconds of the same values each time that the record is executed. Okay. Now the handshake can go a bit faster. You'll see in the .NET application example, it's just set to 1 second is the frequency, but it could go as fast as the controller can support it. But again, waiting for the confirmation back before it resets. Okay, let's stop the run simulation and let's take a look at that data using the SQL Server Management Studio. And we will want to expand under databases. We'll see the tables, and we see the table that's automatically created called data buffer test. And what we'll do is we'll make a query on that table to look at the contents of it. And there we have 83,000 records because we ran the simulation for 83 seconds. Logging all of those records, and we can see the date here. The first record, we've got 619 milliseconds, and the value 1 is 619, value 2 is 61.9. That's simply taking the milliseconds divided by 10, and value 3 is divided by 100. You see that in the source code of the .NET application if you're interested on the emulation. So then we see the next record at the next millisecond with the next set of values. Now, communicating to a controller, you'll be able to achieve the exact same results even though you cannot communicate to that controller every single millisecond. So that's it. That's the technique on how to make it work. Now, one other thing I'd like to bring to your attention is to implement store and forward functionality to disk. That's if your database engine goes down. You want to go under Configure Options. And let's say you're logging to that remote database engine. Under the data buffering directory, you want to enable this property, store data logging buffer to disk on a network failure or database engine. And that's it buffers it both at source and destination. We've got a particular video and guide that talks about that feature and demonstrates it, but that's as easy, that's all you need to do to implement that feature. It's just that, and you're done. Just specify a directory. Don't use the root directory. Just specify some drive and directory on your system to buffer that. Now that's only needed if the database engine is not reachable, and you wouldn't be able to log to that. Or if you're logging to Excel, Excel locks files and makes it to where they're not accessible. And so this is another thing you can do to buffer the data. So when Excel releases the file, all the data would be then uploaded. Now, in the final steps, and that you follow that along in our general guide of data logging, and you'll see it also here at the bottom. It recommends to save your tag configuration and data logging configuration, and then go to Configure Options and set up the default tag and data logging configurations to load. Okay, so that's done right here. Under the data logging configuration, you select Save, and you just select where you want to log that configuration file. Under tags, same thing, select Save, and you can save that. And then under Configure Options, the first tab, the default files, that's where you specify when the operating system restarts, it'll automatically load your tag and data logging configurations. If you'd like to use this data logging and tag configuration with your controller, that's really simple. We just go back to the Configure Tags application and select each tag and change the data source from value to your desired data source that you'd like to do. So if you're communicating to a Siemens controller, you'd want to use that. For the date variables, you probably will need, for Siemens, you would want to use the DT data type. That's something that one of our customers was using. And so that is the particular date variable for Siemens controllers. Again, using Modbus or some of the other types, you want to use a string array for the date. But it's just a simpler matter of changing the data source from value to your desired data source, and you'd be able to connect to that. Of course, OPC servers and OPC UA servers, you can browse to those items. And again, if it's an array of data, as long as all of the arrays are the same length and then the logic within the controller has the handshaking, you're all ready to go. So, and don't forget about the timeout within the controller to implement that. If you have further questions about any of these features, you can contact us. Visit the Contact Us page. There you'll find our phone number, and you can also send us an email to support@oasiot.com.